Hey all, Sean here from Test the Family. Happy summer solstice, June 20th, the longest day of the year in the Northern Hemisphere. Just shy of 15 hours of daylight here in central Maryland on this first day of astronomical summer. Here in 2021, the summer solstice also falls on Father's Day, so to celebrate that, I'm wearing this cool sun-colored tie-dye shirt that my daughter made for me. Well, it's going to be sunny and very warm today with a high temperature of 90 degrees, and while you might expect to see the highest solar production today due to the maximum daylight and high sun angle, here in central Maryland we will likely see a fair amount of cloudiness. We even have some above us right now, as we are positioned between Tropical Depression Claudette to our south and to our north, an incoming front. In this video, let's take a deeper look into the summer solstice. I'll share with you the solar angle for today, the length of daylight, and the solar production numbers from my 7.56 kilowatt Tesla solar panel system. I'll also let you know how cloudiness could impact my solar production for today. Let's jump in. Okay, let's start off with what is the summer solstice. And the summer solstice is best shown by this graphic here. You can see the Earth's axis is tilted off vertical by 23.5 degrees, and that northern hemisphere is angled toward the sun. That puts the sun's direct rays onto the Tropic of Cancer, giving the northern hemisphere the longest daylight hours of the year. This is also the furthest tilt that the Earth will have in its rotation around the sun. The 2021 summer solstice occurred on Sunday, June 20th at 11:31 p.m. The solstice actually occurs anytime between June 20th and the 22nd. Between the 20th and 22nd, you'll see the longest daylight hours of the year. And from this point forward, we'll see shorter and shorter daylight hours as we progress toward winter. Let's take a look at what the sunlight looks like across the globe. This is the Nestis star goes east geocolor image, a full disk image. We're looking at North and South America. And you can see this terminator line, the line between darkness and daylight. You'll see the daylight progress across North and South America, and then we'll see nightfall. Looking to the South Pole, though, you can see the bottom of the terminator never makes it down to the pole, meaning that in Antarctica, they do not see any daylight throughout the year. And looking at the North Pole, you'll see that they never see any darkness. I also want to draw your attention to a little bit of a swirl here in the clouds over the southeast U.S. That is Tropical Depression Claudette. Let's zoom in a little bit further. So I live in central Maryland, and we can see that swirl in the clouds being Tropical Depression Claudette working its way across the Carolinas on the solstice. Further north, there is a warm front progressing through the Great Lakes. So in Maryland, we saw a fair amount of cloudiness throughout the day, a lot of it being high cloudiness, but then in the afternoon hours, we'll see some cumulus clouds develop right about now, and that also impacts our solar production. Let's talk about the NOAA solar calculator. I've got a rough location of my house here with the pin on this map, and then we've got a green line indicating the position of sunrise at 5:43 on the solstice in the morning, and then sunset off to the northwest of my location at 8:38 p.m. Indicated by the red line. Solar noon being the pink line that extends south of my location, that occurring here at 1:10 p.m. in 26 seconds. Solar noon is the highest position of the sun in the sky, and on the solstice that reaches 74.25 degrees above the horizon. Calculating the amount of daylight for my specific location on the solstice, subtracting sunrise from sunset gives us about 15 hours of daylight. It's actually 14 hours and 56 minutes of daylight. You can see between sunrise and sunset, we see sunlight or a large radius across the southern sky. This is great for solar production as long as there's no clouds or weather in the area. Let's take a look at my protractor. I first used this protractor in this video, what's causing these dips. It's a comparison video I posted Last fall, comparing my summer and fall solar production, I saw some unusual dips occurring on days where there were no clouds hardly, and I wanted to figure out what was going on there. So I used this protractor to show the two different days that I compared. One of those was July 14th, 2020, with a solar noon angle of 72 degrees, and the other day was on November 29th, 2020, where the solar noon angle was only 29 degrees. But you can see here at the summer solstice, we had that 74-degree sun angle. It's the highest of the year, arcing over my house, and quite a difference from the winter solstice being only around 26 degrees here above the horizon on December 21st of last year. Let's take a look at my solar production numbers for the summer solstice. Alright, so here are the production numbers for the 2021 summer solstice from my 7.56 kilowatt system located here in central Maryland. On the left hand side, I've got two screenshots from my Tesla app showing the energy usage for the day, June 20th, 2021. And on the left, we can see in yellow is the solar energy produced. That yellow arc is fairly choppy, and I'll talk about why we're seeing that signature in a little bit. The blue color is my home usage from the grid. The green color is my home usage directly from solar, from the panels right into my home. The gray color below the zero line is the solar energy that I pushed back to the grid. All the excess solar that I didn't need in my home went straight back to the grid. So for the day, I produced 33.9 kilowatt hours of solar energy. My home used 16.7 kilowatt hours of electricity. Mainly this is going to be the cycling of my air conditioner compressor during the day. And then you can see here toward the right hand side of the graph at 8 p.m. I've got a setting that kicks on the air conditioner for a steady period of time, and that's what lowers the temperature in my home when we're trying to sleep. During times when we're not producing solar energy, I do have to draw from the grid. That comes from the credits that I have earned from all the previous solar energy that I pushed into the grid. But I did have to draw about 10.5 kilowatt hours from the grid, and you could see on this particular day that I pushed to the grid 27.8 kilowatt hours. So I generated about twice what my home needed for the day, with the largest chunk of home usage being again in the evening hours when the air conditioner was on. Looking at the table on the right, let's compare my summer solstice data to the winter solstice data from my winter solstice video that I shared. Check out the link to that video above if you're interested in seeing my winter solstice data. And yes, there was snow on the ground on December 21st, 2020. I produced 33.9 kilowatt hours of solar energy on the summer solstice. Back on the winter solstice, however, only 11 kilowatt hours. My home used about the same between the summer and winter solstice, just about 2.5 kilowatt hours more here in the summertime, possibly due to the usage of the air conditioner. A huge difference, though, on how much I can push to the grid on the summer solstice. 27.8 kilowatt hours on June 20th and only 7.1 kilowatt hours on December 21st. Let's talk about the kilowatt hour rule of thumb. I did first mention this in my July 2020 production video. Take a look at the link above for information on the kilowatt hour rule of thumb and how much my solar panels produced in their first month. So using the kilowatt hour rule of thumb, really what this gives you is a rough estimate of how much production you might see on a day with full sunshine between the months of May and July. And that estimate between May and July is 37.8 kilowatt hours to 52.92 kilowatt hours. You can see that in the wintertime, the kilowatt hour rule of thumb shows a much lower range, and that's mainly due to the shorter day length and lower sun angle. Yes, my solar production from the summer solstice of 33.9 kilowatt hours falls outside of the range that I show here, lower than 37.8. Why is that? Let's get back to the left-hand screenshot of my Tesla app and the roughness of the solar production curve. That is due to cloudiness. In the summertime, yes, we do have a lot of sunshine, but with the increase in humidity, especially on the East Coast, we do get a fair amount of diurnal cloudiness, or clouds that develop during the day. There's also other storm systems nearby that impact our production. Earlier in the video, I showed that we had a lot of cloud cover moving over central Maryland during the day, and you can definitely see that here in the solar curve. This particular day was not a full sunshine day, and that's why we're below 37.8. Let me give you an example here of what a full sunshine day does look like this time of year. This is back just a few days before on June 17th, where I had a beautifully smooth solar production curve for the day, and I generated 45.6 kilowatt hours. So fit right within the kilowatt hour rule of thumb. That tells me that there are no problems with my system. It's performing without any issues. Low temperature for the day, 66 degrees, and we hit a high of 93 on the solstice. Compare those numbers to the winter solstice, a low of 34 and a high of 44. We did have that variable cloudiness around on the summer solstice, and generally overcast skies with a little bit of late day sunshine on the winter solstice. Daylight hours, nearly 15 hours of daylight on the summer solstice, and only 9.5 hours in the winter solstice. Solar noon about an hour later in the summertime, coming in at 1:10 p.m. versus 12:07 p.m. on the winter solstice. And finally, max solar elevation, 74 degrees above the horizon on the summer solstice versus only 27 degrees maximum during the day during the winter solstice. I show that previously in my protractor image, but certainly quite staggering. If you like this solstice video, make sure to check out this video, 6 months with Tesla solar panels, where I show you how I'm saving over $100 per month. I am also coming up on my 1-year anniversary of Tesla solar, and that video will be coming out around mid-July. So make sure to hit that subscribe button to get notified of all of my new videos. Hit the like if you enjoyed the content here, and make sure to follow us on social media. Alright guys, thanks for watching the video. If you really enjoyed it, make sure you subscribe to Tesla Family Channel here on YouTube. We really appreciate all of our subscribers and everyone who watches our videos. Thank you very much. If you have any questions, feel free to leave a comment down below and I'll get back to you soon. Check out all of our other videos as well. Also, follow us on Twitter at Tesla Family Chan. Use my referral code to buy a new Tesla and you will get 1,000 free supercharging miles. Or if you use my referral code to buy Tesla solar roof or solar panels, you'll get a $100 reward after system activation.